Good morning. How are we? I'm a big fan of a conference where the coffee's on all the time and the food is on all the time. That makes me happy because it means people meet each other and talk and things, which is kind of one of the things I want to talk about today. Welcome to day 2 of NDC. I'm losing count of NDC. I've got a fun topic this morning. I want to think about, outside the building, it says NDC. It says about developers. It's about a conference for developers, and this is great. And then I want to think about what it means to be a developer. Inspiring developers, that's what it says. Inspiring software developers. And so I want to think about what it means to be a software developer. And in order to think about what it means to be a software developer, I want us to go back a little bit and start and look at. So I've been in technology I've been in IT for 30 years. I know, right? I had my first internship with a software games company in 1988. And the following year, I did an internship with IBM, which was very different. And then the third year, I did another internship. It was like what they call a thin sandwich course. So you did these 6-month placements. And my third 6 months, I was a contractor. So I had 3 very different experiences. But that was like in the late 80s. So I want to go way back. I want to look at the Old Testament. Okay, so in the beginning, right? In the beginning, this is 1844. This is all the software, all the code in the world. Does anyone know what this is? Anyone recognize this? It's related to the difference engine. Very good, yes. So this technically is called Note G. This is Note G. So Charles Babbage is designing his difference engines. He's designing the first computational machines. And he's giving talks about these machines. And there's a young lad in the audience, and he's Italian. He will one day become the Italian Prime Minister. He's making all his notes in French because he's basically showing off, right? And all his notes are in French. And Charlie doesn't speak French, so he goes to a friend of his, name's Ada. And he says, Ada, look, would you mind translating this for me? And she says, no, sure, that's fine. And so she's a bit of a polymath herself. She's had an amazing education. And so she starts translating. And on the way through, she makes some notes about the translation because she's thinking about, and so this is one of the notes that she makes. It's called Note G. And what it is it's a description of how you could use the difference engine to calculate Bernoulli numbers. Okay? So it's an algorithm. It's the first algorithm for a computer. No tests. Right? Slightly disappointing, but early days. This is Augusta. Her name is Augusta Ada King-Noel, Countess of Lovelace. We know her as Ada Lovelace. This is all the programmers in the world in 1844, which tells you 2 things. It tells you that all the programmers in the world were female, and they really knew how to dress. Right? Just look at us. Look at the stuff. We're jeans and T-shirts and tat. This is how programmers dress. Okay. So, and her, just a slight tangent. Her teacher was a lady called Mary Somerville, who was the cause of the word scientist. Right. So before Mary Somerville, people who studied science were called men of science. Why were they called men of science? Because they're all men, right? And then Mary Somerville was a scientist, and they couldn't call her a man of science because she clearly wasn't. And so they invented the word scientist to describe Mary Somerville. She was this ridiculous polymath. Go look her up. But she taught Ada Lovelace. She was her kind of governess/teacher. And so she learned things like all the different sciences and mathematics and whatever else, which is how she ended up working with Charles Babbage. So now, this is 1844. And then time passes. 100 years later. Does anyone recognize this screen? You recognize this screen? Oh, it's the best computer game ever. It's called The Hobbit. It's from like 1984 or something on the ZX Spectrum. And it's like a type-in adventure game, and you kind of say, you type in like go north and open box and find key and all that kind of stuff. And then, but you bump into all these characters like Thorin. And what happens is then they start wandering around with you. So you type in wait, and it says you wait, time passes. And if Thorin's with you, it says Thorin waits, because he's nice. You know, so I like that. So anyway, 100 years later, so now it's 1944, and stuff's got real. Okay, we're now in the middle of the Second World War, and now we have a couple of programmers. These are actual hackers. These ladies are actual hackers. According to Wikipedia, their names are Dorothy Dubuisson and Elsie Booker. They are working on cracking the Lorentz cipher, which was the tech inside the German Enigma machine. Again, still women, because programming's still hard. And so we need to start inventing stuff, okay? So this is programmers, and programmers are moving like wires around in machines at this point. And so we needed to invent tools. And this is one of my heroes. This is Admiral Grace Hopper. So she invented the compiler. I said, why did you invent the compiler? Because I needed one. Right? There was a wonderful interview with her on the Letterman show. It's worth looking up on YouTube. And he says, Admiral Hopper, you were, so you were leading this team because you were like a world expert in programming and computers. And she said, no. She said, there weren't any experts in computers. We were making it up, right? And so she had to invent a compiler. She also invented the nanosecond. So she's talking to all these other admirals and whatever else in the US Navy, US military. And she's trying to explain to them why you can't have instantaneous communication with all your ships at sea. Because it's the 1940s and it's the modern age, and why can't we just chat to people in ships? And she says, well, because signals have to travel. So she phones down to the machine room, and she gets them to cut her off these 3-foot lengths of wire, and she'd walk around with these lengths of wire around her neck. And she'd be in a meeting and she'd say, here, have a nanosecond, right? Because this length of wire represents how far light travels in a nanosecond. And so she'd say, right, so now just imagine how many of these wires we need to lay end to end to get up to the ionosphere, and then bounce down again onto a ship, and then it's got to bounce around a ship, bounce all the way back up and all the way. That's the shortest number of nanoseconds that it can take to get a signal. And they're going, oh, right. She also had microseconds that she'd carry around, but they were much bigger. Right? So she didn't hand those out so much. And so she invented stuff. And then what happens is people start to specialize. And this is now the 1960s. This is an academia mainframe. And this is generally what happens with tech. It tends to start in the military complex, then it goes into academia, and then it goes into the commercial world, into business. So now universities are starting to get this computing technology. It's the 60s now, so programming is simple enough for even men to do. And these two guys are debugging a mainframe. They're pairing, which is nice. So that started early. But they're specialists, right? This is what they do. And so then we've got commandments, right? This is how software gets written. You shall have a business requirements document, okay? We have to do that. You shall have a functional specification derived from the business requirements document. You shall program in the manner of the specification. Thou shalt have no other specification before me, for I am a jealous project. Analysts shall analyze, architects shall architect, and this is what happened, is we specialize into these roles. Programmers program, testers test, right? And this is how we roll. There's more commandments, okay? So we say things like, you shall complete a formal change request. You can't just go changing stuff, don't be silly. You think we are? You shall provide release documentation. You shall not release to production yourself, lest you incur the wrath of the release manager, okay? You shall not hack on that which is in production, which is more of a guideline, really. But basically, this is how we rolled. And this was my early career. This is probably the first 10 or so years of my career. And in fact, we had a thing in the early 90s called an analyst programmer, which was this crazy hybrid thing of people who did both. They were quite rare, it turned out. So we put them back in their silos. And then something happened. It had kind of been bubbling up through the whole of the 90s, but it erupted at the beginning of the 21st century, beginning of the 2000s, came a New Testament, okay? And it was this bunch of jokers. So Linda Rising famously calls this the Council of Middle-Aged White Guys, this is Bob Martin, called together all of the smart programmers he knew, which were mostly middle-aged white guys. And And he got them together at Snowbird, which is a lovely ski resort in Utah. And he said, listen, he said, we've all got much more in common than we have different. Let's think about how we build software. And so they drafted the Agile Manifesto. I don't need to tell you about that. Who's not seen the Agile Manifesto? There, that was easy, right? I love that that's just normal now, okay? It hasn't taken that long, 20 years. So here's the Agile Manifesto. We are uncovering new ways. I love that. I love the humility of that. We haven't solved programming. It's really hard. We're uncovering new ways. This is as far as we've got. It's a progress report. We think that processes and tools are important, individuals and interactions are more important, and so on, right? And so I was not a producer of this. I was a very early consumer of this document. So I was I was in the late 90s. I was kind of discovering XP and whatever else. And so then when this Agile Manifesto was published in 2001, I got really excited. I was like, yes, that's what I've been trying to describe. And so, wow, my head exploded, and it was really exciting. And then we get into kind of where we are today, right? And where we are today is we're not in silos anymore. We're not analysts, testers, programmers, whatever else, and even in the organizations where we do have that kind of demarcation, we're not working on our own anymore. We're not working in isolation generally. So I'm all kinds of different things. I'm a developer, right? I still cut code 30 years in. I still love hacking on things. I'm removing my data. I'm taking all my photos out of Flickr at the moment because they said they were going to delete a load of my photos. So I'm taking all my photos out of Flickr and I'm reconstructing all of my photo albums from the metadata in JSON files using Python because it's fun. It's a little thing I'm hacking on. Great fun. I'm a developer. But then when I'm in an organization, I'm a developer in a team. I'm not on my own, okay? And we're building a product. And that product exists on a platform or on a series of platforms within an organization. In a department, so it's not just my team, there's a whole bunch of other teams. And that department lives with a bunch of other departments in an organization, okay? And so when I start thinking about myself in that way, suddenly I become this multi-dimensional creature. I'm not just a programmer, a developer. But I'm not here to talk about me, I'm here to talk about you. Because you are all these things as well. Now, this isn't just targeted at developers, okay? So whatever role you're in, all of this is true, with the possible exception of the first one. So put whatever hat you wear in as that first one, and we'll be fine. But let's unpack some of these things. So you're a developer. What does that mean? What does that mean for you to be successful as a developer? Well, clearly you need to learn a language, okay? We're at a NDC. It has a Microsoft-y bias, although I've noticed over the years it's become much more broad church. But you need to learn your language. You need to learn your C#, your F#, your whatever the tooling is. But that's not enough, right? Because the language, typically the syntax, the words, all of that stuff isn't the hard bit, right? You can learn most languages pretty quickly. Once you've learned a couple, the next ones are pretty straightforward. You really need to learn the libraries that sit underneath that language. And again, different languages have different opinions about different kinds of libraries. How many Java people here? Okay, there's a handful of Java. Get them! No, don't. No, be nice. They came. Hey. So in Java, and well, actually in C# as well, but certainly in Java, the standard libraries, the core libraries, are really quite haphazard. And I'm being generous, right? They're a bit all over the place, okay? Try and do anything in dates in Java, about Java 9, right? It's just completely bonkers. There's a thing called Java util, which you can think of as a library-shaped rug, okay? And you just sweep everything that you're not sure about into Java util. It's got all kinds of nonsense in there, up to and including Gregorian calendars, right? So understanding the libraries. So if you have a language that's been designed fairly, I guess, in the modern age. But you think of a language where people who've designed the libraries have designed the libraries to be largely homogeneous, to be simple, to fit in your head. So anyone using Go? Anyone using Go as a language? A few hands going up. So all of the Go libraries kind of look like all the other Go libraries. If you've done stuff with the HTTP library, the SMTP library is pretty obvious, and so on, right? In a lot of languages, what's something that, well, PHP. PHP is probably the prime offender in terms of completely arbitrary naming of things and structuring of things. So we need to learn the libraries. But that's not enough to be a successful developer, because you need to also see what's going on in the ecosystem. Okay, what other choices do I have? What other options do I have? I've seen the more effective .NET developers I know can move seamlessly between, for instance, C# and F# for different kinds of problems, often in the same code base, which I think it shows a way of thinking about a problem. They monitor alternatives. They look at different tooling, tool chains, whatever else coming along. In the JavaScript space, this is clearly nearly impossible. Days since new JavaScript framework, 1, 2, 0. There we go. And you learn the tool chain. So again, it's not enough to be able to cut code. You need to understand what it means to build and deliver that code. And again, the successful developers engage with the community. Everyone in this room is at a conference. Well done, right? Everyone in this room, if you haven't already, go up to someone in the next break, go up to someone in the remaining days of this conference, and talk to a stranger. Go and talk to someone you've never met before and say, hi, I'm Dan, I'm from so-and-so. Don't say I'm Dan unless you are, right? That'd be silly. But say, introduce yourself. I'm from wherever. I'm here to learn blah. Tell me about yourself. Meet some people. But engaging with the community can be all kinds of different things. It can be going to meetups. It can be speaking at meetups. It can be hosting meetups in your company. Okay, so that's you as a developer. All right, but now let's unpack that a bit more. And say, well, okay, that's even if you are really, really successful and really effective as a developer, you're in a team. And that means you need to learn to play nice, right? So that means you need to understand how your team works. Okay, you can take a really successful team, inject someone who's a great programmer, and you get terms like rock star and ninja and all this macho nonsense. I hate all it. And this person goes into a team and starts throwing their weight around, and guess what? The team's effectiveness plummets. Okay, a team is more than a group of really smart people. It's a joint enterprise. It's a group of people working together. So let's understand how we as a team do work. Let's understand how we succeed. Let's understand who does what in the team. Okay? And sometimes those roles are deliberately very blurred. We're all team members doing stuff. But even in a team with team members doing stuff and very blurred edges, we're still thinking very much about, we start to understand different people's strengths and weaknesses and what they like to do and what they don't like to do. And that might not be technical stuff. For instance, you might find, I'm a big proponent of neurodiversity an understanding of neurodiversity in teams. So you may find that some people in your team really don't like working with other people, like being forced to pair. They hate it. They find a massive invasion of their physical space, or they're just, they're somewhere on a spectrum and they're saying, this is really uncomfortable for me. We'll find out how that person works and what works for them. We need to collaborate with people. We need to learn to play nice with others, okay? And when I say others, I mean all the others. Okay, so we need to learn to play nice with everyone in our team, not just our favorites. Okay, that's super easy, super tempting, right? Learn to practice playing nice with other people, with the whole team, and also outside of the team. So this isn't just your teammates. This is other stakeholders as well. And take time to attend to the team's health. The team is an organism made up of human beings. Okay, is that a happy team? Is it an effective team? Is it a team that likes to hang out together? Is it a collaborative team? What can you do in that team to make it a more effective team? Right? And to paraphrase something Martin Fowler once said, if you can't change your team, change your team. Right? It may be that you're just not in the right place anymore. So this is you in a team. That team is building a product. Okay? It might be building a service. Edwards Deming said the difference between a product company and a service company is a service company doesn't know it has a product. Okay? It's all a product, right? Everyone is doing work to meet someone's needs in the form of a product. We're building a product. So what does that mean? That means we need to understand why we're here. If you don't understand what it is you're doing, you can't know if you're making progress. You can't know if you're going in the right direction. Okay? So understand the business objective for this. Understand the domain. I'm working with some business leaders, I guess is probably the right way to describe it. Basically very wealthy people who are trying to build products to have a significant impact on various parts of the world, okay? And almost universally, when I speak to these people, the message I get again and again is, do you know what, programming, the technology part of it is largely, we can solve that. What I find really, really hard to find are people who deeply, deeply understand the domain we're trying to work in so that we can articulate the problems well. People who deeply understand healthcare, people who deeply understand agriculture, people who deeply understand finance, how money moves around, people who deeply understand education, okay? Getting those people into our world, right, and really, really being able to understand what the needs are that we're meeting within those domains is hard. It's hard. You can spend a lifetime studying any one of those domains, in fact, parts of any one of those domains. It's like the deeper you go, the more and more you know about less and less. And we need to understand the stakeholders, right? What's a stakeholder? I'm going to throw this out. It's a question. What's a stakeholder? How would you define a stakeholder?
Somebody who's got like a finger in the pie.
Someone who's got a finger in the pie. I love that. Someone's got a finger, ideally not in your pie, because that would be unhygienic. Yeah, so someone who's got a finger in the pie, sure. What else? Someone who's got an interest in what you're producing. I'm going to broaden that. Anyone who's got an interest in what you're producing. In fact, my favourite description of a stakeholder, a chap called Mark McNeil came out with this years ago. People whose lives you touch. Right? Stakeholders, people whose lives you touch. Anyone whose lives you touch by doing work. So clearly, if we're building a product, we've got some end users in mind. We've got some people who are going to interact with this application, with this product, with this service. That's one set of stakeholders. You've got some people paying for it. They're stakeholders. But then if you look across the organization, you've got things like security and compliance and legal and all those kind of incidental people who really care quite a lot about how we build what we build and how we deploy it and how we operate it. And then you've got people like operations and support, technical support people who are going to get paged at 4 o'clock in the morning, right? So, you know, all the stakeholders. The map of stakeholders is generally a lot wider than the people we think of when we say stakeholders. We tend to use stakeholders and users synonymously. Stakeholders is a much bigger group of people than that. And we tend to, when we're building a product, as a developer, with our tunnel vision, hacking away on our thing, lose sight of the bigger picture. Okay, so it's about panning back. You want to engage as a consultant to your product. I'm building this thing, but I'm sharing why I'm building this thing. I'm learning why I'm building this thing. I'm putting it in front of people. I'm getting feedback. Yeah. And I want to contribute to the product. I want to contribute to it in terms of learning. What I've noticed as well is a lot of product companies, the people building the product are consumers of the product. So if you go to Spotify, everyone at Spotify has a Spotify account. I was working with John Lewis, retailer. You know, everyone in John Lewis IT, guess where they shop? Right? Guess where they buy their groceries, right? So I've got a room full of customers. Yeah, you don't have to look far. And so on. And you go into a bank, and most of the people in most of the banks I work at will bank with that bank or will have some products with that bank. So we tend to often be consumers of our own products, which is useful. But don't be afraid to contribute to the product in terms of product ideas, not just in terms of cutting code. But we're building this product in an ecosystem, right? We're building this product on a platform. And what does that mean? That means we need to understand not just .NET, .NET Core, WPF, TLAs, right? Microsoft technology. That's not enough. In fact, that's probably not even enormously useful, right? What's much more useful is understanding the ecology within the organization you're working in. Understanding what platforms are there, what tooling is there, why those things are there. Get the story behind that platform. Why is this thing here? Understanding your path to live. Right? It's not enough these days to be able to build something. We need to be able to get it into production. I've seen a wonderful, wonderful shift in the last, I'm going to say 2 years, largely due to one individual called Charity Majors, who, if you haven't come across her, she's a very sweary American. Very smart lady. So she's been socializing the meme of observability. So what she's done is she said, we've got monitoring and alerting and all that stuff, and we've gotten good at that. She said the problem is we're solving the wrong problem. The horse has already bolted. By the time you're thinking about monitoring and alerting, it's too late. Because the thing you're monitoring or alerting wasn't designed to be monitored or to alert, right? She says we need to go much, much further up the food chain, right back to design, to architecture, to tooling, to think about observability. How do you build systems that are observable? If we can build systems that are observable, that have observability as a first-class characteristic, then monitoring's trivial, right? You just start observing. Right, if you start observing something that was designed to be observed, it's telling you all kinds of stuff. Yeah? Mostly we're trying to reverse engineer that. So understand the path to production, understand the things we're building. We're not building them out of vanity, we're building them to serve a purpose, and to make sure that we can know that they're serving that purpose while they're running is a big deal. Caring about runtime concerns. Okay? So again, it's not enough that it's running, it's enough that it can be seen to be running. There's been a lovely shift from mean time between failure to mean time to recovery. So mean time between failure, let's build these super secure, super resilient systems. What happens though is at scale, stuff breaks. Once you get to tens of thousands of servers or instances or whatever it is, there will be some non-zero percentage of your estate that is currently broken. We can't think of this binary working, not working thing anymore. There's levels of brokenness. And so what we care about is how quickly can we observe, how quickly can we rectify that situation, and if we can make it appear as though the tree never fell over in the forest, then no one heard anything. Right? And Netflix is a canonical example of this with Chaos Monkey, but again, we're seeing this whole meme of chaos engineering emerging, which is really exciting. So it means that I don't have a single instance running. I might have multiple instances running side by side, all doing the same calculation, so it doesn't matter if some of those fail. But I know I replicate that between data centers in case the whole data center fails and all those instances die. But then I replicate those data centers between zones because the whole zone might go down, and so on. So you get this sort of fractal availability pattern. It's really, really powerful. And again, if we design that from the get-go, if we build systems with that in mind, it's easy. If we didn't build it with that in mind, making it do that is really hard. We care about automation. Okay? Probably the single most useful way to free up your time, to free up other people's time, to eliminate human error, all of that stuff is automation. What I will say, though, is not all the automation. Okay? Do not automate all the things. I've seen obsession about automation, and it's not helpful. So I'll give you a quick example. I was working with an organization a few years ago, and they'd built this one chap there, his name's Keith, he'd built a build pipeline. And back in, a long time ago, about 2006 or something, I co-authored a paper called the Deployment Production Line, and so we started introducing this idea of build pipelines. And so I turn up, and he says, oh, you're the build pipeline guy. You've got to come and see this build pipeline that we've built. And he shows me, and it's a thing of beauty, and it's kind of instrumentation and dashboards and blah. And I said, brilliant. I said, that's great. What impact has it had? He said, what do you mean? I said, well, clearly you've spent a lot of time. He said, yeah, months. I spent months building this. Great. What impact has it had? And he said, I don't know. So I said, okay, well, let's measure it. So we just use Post-its, and we did a value stream map of the path to live. So from I've got my thing, I've written my feature, to the feature's live, what are all the steps that need to happen? And it turned out this process took weeks, right? It's a really embarrassing amount of time. And in most organizations, it's long, because we don't measure it. When we start measuring it, it's embarrassing, and then we can go after it. But so of this weeks, all of this automation had reduced the lead time to deployment by 45 minutes. Awkward. So oh, okay, that's annoying, because it turns out that most of the lead time was waiting for meetings, waiting for people's availability. This sign-off only happens every week or every 2 weeks or whatever it was. And so actually automation wasn't going to help us much. But he said, I'm not going to be defeated. He said, that's really useful. The next time I saw him, which was only a few weeks later, he had halved the time to production. Excuse me, because now he knew what the enemy looked like, right? He knew what we were going after. And the next time I saw him after that, he'd halved it again. yeah, because he was getting really good at this. So once you understand why you're doing something, then you can have automation in your back pocket as a tool. But we tend to, and I'm just as guilty of this as anyone, right? Especially as engineers, we see everything as a programming problem, right? I can automate this, I can automate it away. Yes, you can, that's an option. What impact will that option have? What other things could you be doing in the meantime? And again, you contribute to the platform. That platform might be an open source platform, it might be an open source tool. I'm seeing a really lovely feedback loop now where very, very commercial and secretive organizations like banks are becoming major contributors to open source tooling. Right? That's really exciting. That says that they're taking this stuff seriously and they don't mind contributing. And you're in a department, okay? So this now is, it's bigger than your team, and it might be bigger than the platform that you're targeting. Okay, so what does this mean? It means you understand the wider context. You understand what it is that we're trying to build. So I can see what my piece is. I can see how my piece is part of a bigger puzzle, which means I can make trade-offs. You know, yes, I would love to use tool X. It's my favorite tool, and I know it really well. But actually, everyone else is using tool Y, and which will do. Honestly, it's fine. Yeah, I'm just being a little bit precious about wanting to use tool X, right? And everyone else is using Y. And honestly, if I use tool Y, I'll get the job done. And also, there's a whole load of brains trust already in the organization. Because it isn't just the coding bit, remember. It's the deployment, it's securing it, it's patching it, it's running it, it's observing it. It's all of that stuff we already know how to do. Where tool X might be my favorite database. Right? So I might be an open source nerd and say, I want to use MySQL here. Yeah, but we're using SQL Server everywhere else. We're a Windows shop. Right, but I want to use MySQL. And honestly, it's a relational database. They're basically the same thing. I want to use, and then guess what? You do it in SQL Server, and you've got a bunch of really smart DBAs kicking around in the building who can help you. Right? So we need to start thinking broader than ourselves. We want to share our knowledge across the teams. And this isn't just about being willing to do that, it's about having the infrastructure to do that. So things like communities of practice, things like having wikis and chat groups and mail lists and forums and ways in which organizations can share knowledge outside of the hierarchical team to bigger team to boss type structure. We want to go horizontally. I'm working with a bunch of organizations at the moment where we've got maybe several thousand people. And those several thousand people are working in teams of 8 to 10 people, and those 8 to 10 people have no idea what's going on next door. Right? All really smart people, all doing really great stuff, no idea what's going on next door. Okay? It's not difficult to solve that problem. It just needs to be a choice to go after that problem. There's a lady called Emily Webber who's been doing a load of stuff in this communities of practice space. She's written a brilliant book called Building Communities of Practice. It's brilliant because it's really small. I'm a big fan of really small books. It's a really small book about building communities. I recommend it. All your knowledge, right? So something I've noticed, and I've seen it many, many times now, more times than is a coincidence, is that your team might be doing something, and it might be some really trivial little hack that you put together you wouldn't think anyone would be interested in, and someone else sees it and goes, whoa, what did you do? That's magic. What are you doing there? Oh, well, we just plugged this thing into that thing, and it's like, oh my, why didn't I think of that? It's been staring at me. Oh no. You've just saved me weeks. You've just saved me weeks of running around in circles because you plugged that thing into that thing. You're a genius. Well, not really. I just plugged the thing into the... So we do this all the time. We come up with little tools, little ways of doing stuff that we don't think are worth sharing, right? It's amazing, the tiny little things. This is part of the magic, part of the power of pair programming. You work in a pair, and it's not just the two brains solving a problem dynamic, which is really powerful. It's the, what did you just do there? What secret keystroke in Visual Studio or Rider or whatever? What did you, oh, you mean you don't know about Shift, Escape, knee on the desk, elbow? Because that just, wow, okay, that's going in my back pocket. And so you end up, the team ends up as smart as the smartest ideas in the team. They percolate out. And now imagine that across an organization. You have an organization that can move at the speed of the smartest thoughts in that organization. It doesn't matter whose head they come out of. Goldman Sachs, one of the one of the first banks to realize that it wasn't a bank, it was a technology company doing finance, okay? They're a weird organization. Weird from a technology point of view, weird in a positive way. So you'll go to a technology conference and the headline sponsors are like, Microsoft and Oracle and Goldman Sachs. And you're like, why is a bank, a tier 1 sponsor of a technology conference? And it's because they think of themselves as technologists. Again, big net contributors to open source. And one of the models they talk about very early on, if you navigate your career through there, is they talk about impact and influence. So the way they measure you in your career as you move through is impact and influence. So impact is what do you do? So as an individual, what's your individual contribution? And then as you move through the organization, it's less about your impact and more about influence. What can you cause to happen? And the 10x developer isn't about being 10 times as productive or 10 times as whatever. It's the developer who can influence 10 other developers and make them better, okay? So the real 10x developers are anonymous because they didn't do the work. They encouraged other people to do the work. Right, so think about that next time you see famous programmers. And you're going to contribute to the department, okay? So again, the department is an organism made up of team organisms, made up of human organisms, okay? And it has its own culture, it has its own life, it has its own vibrancy. And we're looking to influence across the organization. So how do you build those relationships? Again, if I'm going to be a really effective developer, it's about having relationships into the downstream, into the people who are going to be, operating the tin, if it's not me. Upstream into the commercial side, the business side. Horizontally into finance and HR and operations and all of the business type support functions, right? It's knowing how to navigate that space. And finally, you're in an organization. So what does that mean? That means that you share the organization's values. There's a really simple test that I recommend you do, that I recommend to people in general. And the test is this. Think about where you're working. Would you proudly wear a T-shirt that had that name on it? Right? That's quite a simple test, yeah? Most people I have this conversation with, they're like, actually, yeah, do you know what? And even if that organization might be in the news or having a bad time at the moment, they're like, do you know what? We're going to weather this. Yeah, we've done some stupid things or, whatever else has happened. Do you know, actually, I reckon net, I'm in the right place. Do your values align with the values of your organization, of your employer? And I've been in places where for many years they were very much aligned. And then I noticed they started to diverge. And when they start to diverge, you then have a couple of choices. One is you can try and bring them along with your values. One is you can decide that you're going to realign your values. And a third is you're going to part ways. You part ways as friends and you say you're going in that direction. Good luck, I'm going in this direction. So protecting the organization's values. You care about their reputation. It's the thing where when you're a kid and you're walking home in your school uniform, for those of you who had school uniforms when you were kids, there were certain things you just didn't do when you were in a school uniform on the way home, right? Because actually you're an ambassador for the school. And likewise, you're an ambassador for the organizations you work in. And that's especially true if you're independent, because you now are your organization. And it's especially true if you're in a consulting role or an advisory role where you are out into other companies, into other contexts, being that company. I've seen people who are really smart, clearly really dedicated, act like absolute idiots, really let themselves down, really not do their company reputation any good by being completely oblivious to the impact they're having in a situation. Right? So it's about that self-awareness. Sharing your knowledge externally, speaking at conferences and all that. Be careful. Some of this stuff is proprietary. Some of it you've got to be very careful what you are allowed to talk about and you're not allowed to talk about, or what's not appropriate to talk about, and those kind of things. One place I was working, I accidentally, because I thought they were an amazing organization, and I wanted to tell the world about what they did. And I started telling the world about what they did, and they said, you can't do that. I was like, oh, Oh, yeah, I know, I get that now. And so now there's this one chap I used to work with who was very, very good at the, what should be internal analytics. And now whenever I talk about that organisation, I imagine he's sitting on my shoulder. I'm like, can I talk about? No, you shouldn't. Okay, right, I'll leave. So you're getting that sense of what's okay. And again, you contribute to the organisation. So now this is at a broader, this is maybe at a strategic level. This is as you're kind of growing in your career. So you are a developer or a tester or a project manager or whatever it is you do. You are a contributor in a team. Okay, you're building a product on a platform, in a department, in an organisation. Okay, so you are beyond developer. There's something I wanted to add to this as well, because I've given this talk a number of times and it's iterated a number of times. So last year I became a dad. I adopted a little boy, and he's wonderful, and I'm very happy. And I realised that even when we talk about all these different dimensions of who you are and how you're a developer and how you're a contributor and how our role has evolved over the years, there's a really important additional message as well, which is you're beyond developer in terms of you are a person in the world, right? So you're beyond your job. You're not just defined by your job. So, and you can think about who you are along two axes. You can think about what I call circumstances and choice, right? So circumstances is where you're born, is your socioeconomic situation, is your physicality, your height, your skin color, your gender, all of those things, okay? The choices you make are your values, your beliefs, your family, friends, faith, or not faith, or wherever you choose to be in that space, and think about all of that and what they call bringing your whole self. Bringing your whole self, being authentic in the workplace, being authentic in your relationships, is as much about being beyond developer. Right? So I'm a Christian. I self-identify as a Christian. And it's interesting because you get into these discussions about like your faith life and your secular life, and I'm like, I don't have that distinction. I'm Dan in all the different contexts. I'm not going to go up to people and Christian them. I'm not going to go and shove my faith down people's throat. I don't think that's okay. But I'm not going to not, have those values and not think those things because I'm at work or because I'm at a conference or something like that. So, and it's about, I think, being honest with your identity and being authentic with your identity is about being beyond the silo that you might be being that other people might be putting you into. So I appear to have finished early. So I've actually got a bunch of time, I think, to kind of take some questions. But I just want to finish with this lovely, lovely quote. It's an African proverb, which I like. If you want to go fast, go alone. Okay? If you want to go far, go together. And I have an addendum to this, which is, if you want to go far quickly, pack light. Okay? So that was all I wanted to say. So thanks very much. If you have any questions, I'm happy to chat. Otherwise, you can beat the rush for lunch.